Hi, this is Harikrishna. In this video, we discuss about covariance and correlation coefficient. Now first, the definition of covariance is it is a measure of the relationship between two random variables x and y. That is, if x and y be two random variables with means x bar and y bar respectively, then the covariance gives the relationship between two variables. The covariance between two variables is given by the relation covariance of x comma y equals to expectation of x minus x bar into y minus y bar, or covariance of x comma y equals to expectation of xy minus expectation of x into expectation of y. Here we have important note. Point number 1, the covariance of two independent variables is 0. That means if we evaluate the covariance for two independent variables, that gives 0. But the converse need not be 2. That is, if the covariance is 0, then the two variables may or may not independent. Coming to the point number 2, if small a and small b are constants, then covariance of x plus a comma y plus b equals to covariance of x comma y. Covariance of ax comma by equals to ab into covariance of x comma y. Third point, if x1 y1, x2 y2 and so on xn yn be n pairs of observations on two variables x and y, then the covariance of x and y is given by covariance of x comma y equals to 1 by n1 into summation I equals to 1 to n xi minus x bar into yi minus y bar, or 1 by n into summation I equals to 1 to n xi yi minus x bar y bar. Now we define the correlation coefficient. Correlation coefficient is also measure the association between two variables, and the range of correlation coefficient is -1 to 1, and it is denoted by R. Now here we have important note. If R is close to 1, we say that the variables are positively correlated. That means there is a strong linear relationship between two variables with positive slope. That means, is there any increase or decrease in the variable of 1 is accompanied by the increase or decrease in the value of the other variable. That means if the first variable increases corresponding to that increment, the second variable is also increases. If it is decreases, that means the first variable decreases, then the second variable is also decreases. That is a positive slope. Now, if R is close to -1, then there is negative correlation. That means there is a relationship between two variables that is with negative slope. That means if there is any increment in the first variable corresponding to that increment, we can observe the decrease in the second variable. That is opposite relation. If there is decrease in the first variable, then we can observe the increase in the second variable. That is negatively related. Now the third point is, if R is close to 0, we say that the variables are not correlated. That means there is no relationship between two variables. Now we can observe in this diagram, positive correlation is like this, negative correlation is like this. There is no relation or no connection. Now if you observe, covariance and correlation both measure a linear relationship between two variables. Now if you observe, what is the main difference? Covariance indicates the direction of the linear relationship between variables, and on the other hand, correlation measures both strength and direction of the linear relationship of the two variables. correlation is a function of the covariance. Now, correlation coefficient are used to measure strength of the relationship between two variables. In general, here we widely use Pearson's correlation coefficient, that is given by the formula R equals to covariance of x comma y divided by sigma x into sigma y, where sigma x is the standard deviation of the sample data x, sigma y is the standard deviation of the sample data y. Here we have different forms of the formula for the correlation coefficient. We have different formulae. In general, we use this formula n into summation xi yi minus summation xi into summation yi by square root of n into summation xi square minus summation xi whole square into square root of n into summation yi square minus summation yi whole square. Widely we use this formula only. We have different forms, but we use the first one. Now coming to the example problem, the time x in years that an employee spent at a company and the employee's hourly pay y for 5 employees are listed in the below table. Calculate and interpret the correlation coefficient or include a plot of the data in your discussion. Now given x, years, y, hours, pay. We use this formula R equals to summation xi yi minus summation xi into summation yi by square root of n into summation xi square minus summation xi whole square into square root of n into summation yi square minus summation yi whole square. So we have to evaluate first summation xi yi, summation xi, summation yi, summation xi square, summation yi square. With the help of table, we evaluate all these. Now given data is x and squares of the first one xi squares, the sum of xi square equals to 375, sum of x is 37. Take the y values, hourly pay, and sum of these values summation y equals to 139, and squares of these values summation y square equals to 4135, and product x into y equals to, we have these values, and the sum is summation xy equals to 1189. Now the coefficient of correlation is given by R equals to n into summation xy minus summation x into summation y divided by square root of n into summation x square minus summation x whole square into square root of n into summation y square minus summation y whole square. Now substituting the corresponding values, n is 5 into summation xy 1189 minus summation x 37 into summation y 139 divided by square root of n into 5 into summation x square 375 minus summation x whole square, that is 37 whole square, into square root of n into, that is 5 into summation y square 4135 minus summation y, that is 139 whole square. That gives R equals to 802 divided by 827.72, that equals to 0.97. If you observe, R is very close to 1. That means there exists a strong positive correlation between number of years of employees has worked and the employee's salary. Now coming to the next problem, the table below shows that the number of options X in a calculus course and the final exam grades Y for 7 students. Find the correlation coefficient and interpret your result. Given options of the students X and Y their grades. So to evaluate the correlation coefficient, we have to find summation x square, summation y square, and summation xy. Now using this table, the given data x 1026433, the sum is 19, squares of the given data and evaluating summation x square that gives 75. Take the second y 95, 90, 90, 55 and so on. Summation y equals to 565. Squares of the y 9025, 8100 and so on. Summation y square equals to 46,775. Now evaluating the product x into y, and the sum is 1380. Now coming to the correlation or coefficient of correlation, R is given by n into summation xy minus summation x into summation y divided by square root of n into summation x square minus summation x whole square into square root of n into summation y square minus summation y whole square. Now substituting the corresponding values here, n equals to 7. 7 into summation xy is 1380 minus summation x 19 into summation y 565 divided by square root of n 7 into summation x square 75 minus summation x whole square, that is summation x 19 whole square into square root of n 7 into summation y square 46,775 minus summation y, that is 565 whole square, that gives R equals to minus 1075 divided by 1159.66, that gives minus 0.93. Here if you observe, R is very close to minus 1, so there is a strong negative correlation between the number of options and the final exam grades. That means if options increases, then the final grade will be decreased. So these are the problems on coefficient of correlation. In the material, I have already solved some example problems for the practice purpose. In the next video, we will continue.